Are von Neumann probes coming soon? What will it take to categorize all neighboring stars? What are the promised discoveries from Vera Rubin? And in Q&A Plus, which dwarf planet should we visit next? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. I am continuing to record from this quiet alley that I found in Kyoto at 6 in the morning in Japan. And next time I'll be somewhere different, but still on the road. All right, let's get into the questions.
Henry Warren, do you think von Neumann probes are coming soon? I heard about the Blue Alchemist rovers, and that made me think that these probes could be coming soon. So Blue Alchemist is a plan from Blue Origin to do in situ resource utilization, ISRU. And so they're planning on scooping up regolith from the surface of the moon and then processing it into various useful substances, metals, oxygen, maybe make water, various volatiles. Like they've got a whole laundry list of things that they're trying to do. And this is interesting and exciting enough to NASA that they've been funding them. I think they gave them like $100 million to continue some tests. We should be seeing some actual practical tests of the Blue Alchemist, even on the moon in the next couple of years, which is great, really exciting. But just digging up regolith, using solar energy, turning that into little piles of iron or titanium or magnesium out of the regolith or silicon is a long way from having a chip fab that allows you to actually manufacture the chips that would be required for you to have artificial intelligence for your spacecraft that could be then making copies of itself out of the asteroid belt and so on. So no, we are nowhere near close enough being able to build von Neumann probes. But there was an interview that I did about 2 years ago, maybe. And that this is a researcher who was sort of laying out how you might actually build a self-replicating robot factory on the surface of the moon. And the trick is that, here on Earth, when we think about the chips, when we think about the chips that are on our phone or our computers or whatever, it is built with what are essentially the most expensive machines on Earth. The chip fabs, they're only designed out of this company out of the Netherlands. Only companies in Taiwan are able to produce them at the 3 nanometers that they make these things at. It's absolutely a feat of modern engineering that you don't realize the wondrousness of your phone, of the chip that's inside your phone. But you can go back generations to much simpler versions of microchips, wiring, transistors, things like that. And you can actually get a certain level of intelligence, of capability. And so this researcher that I had interviewed, he was talking about how a lot of the big stuff is relatively straightforward. You can dig up regolith and you can turn it into solar panels. That we pretty much have we know how to do this. Like, it hasn't been practically done yet, but this is the kind of test that Blue Alchemist will do, is can we build solar panels on the moon, for example? There's a different kind of solar panel technology. So there's the main kind of solar panels that you're familiar with. Those are made with silicon and gallium, I think. That is very complicated. They're essentially kind of like microchips to build. And then there's this other technology called perovskite. And perovskite is much simpler. The problem is that it's very easy to oxidize. That if you built perovskite solar panels in the Earth's atmosphere would wear them down and they would become useless. But when you're on the moon, it doesn't matter. And so you could build these perovskite solar panels on the surface of the moon out of the regolith, and people have come up with methodologies to be able to do that. And so you can sort of start to make your way towards building a copy of your robot factory on the moon. And so the researcher that I was talking to, he was proposing that you send up the intelligence, and then it has little worker robots, and they gather material from the surroundings and then start to form the various components that are required. Solar panels, very rudimentary chip fab, other instruments that you might want. And it's great. So I used to work for this offshoot of the X Prize called HeroX. They're still operational, but I don't work with them anymore. And it was a way to sort of let regular people crowdsource challenges. And the challenge that I wanted to come up with is, like, can we build a self-replicating robot? Like, whoever can build, like let's all gather our resources together. Let's come up with a prize, say $100,000. And then whoever can build a robot that can make a copy of itself as well as possible wins the prize. And then every year you just keep running the competition and they just keep trying to make a robot that makes a better copy of itself. So, and that's how we get to von Neumann probes. So I think in the short term, we are very far away from von Neumann probes. This idea of self-replicating robots that would go out and explore the galaxy. Like we don't even have the technology to explore the galaxy yet. But this is the kind of thing that I think will be inevitable, that in a couple of 100 years, maybe sooner, we will have mastered 3D manufacturing. We will have mastered the kind of propulsion technologies that might take you to other star systems. We will be able to build a robot that can build a copy of itself from square one. I mean, that's what bacteria does, right? Like we see life doing this. We must be able to figure out a way to do it ourselves.
It's time to shout out all the new $5 patrons and above. Smashley83, Joe Deshawn, The Chicken Shrink, Jamie Neumann, Earl, Tommy Moiso, Matt Baker, Richard, Scott Barnett, and Scott Ware. Join the club at patreon.com/universetoday.
Funky Loiso, what kind of mission would we need to categorize every star system in some radius around us? This question that you were just asking me is like a version of the question that I am always asking astronomers, because, man, it would be amazing if we could look at, say, all of the star systems within a 10 light year radius of us. Like I think there's 10 within 10 light years of us, or within 100 light year radius. And then I think there's 1,000 star systems in that region. And like, what would it take for us to just know what's in that star system in the way that we know what's in the solar system? We know that we have the 8 planets plus the dwarf planets plus the Kuiper belt plus the asteroid belt. We know about the moons that are going around those planets. And the two main methods of observing exoplanets is the radial velocity method and the transit method. And those both are, you need the star and the planet to be lined up from our perspective. So with the radial velocity method, you've got the star and you've got the planet is orbiting around the star, and it's causing the star to kind of move towards us and away from us a little bit. And we measure that change in the speed, because essentially the planet is pulling at it with its gravity that's in front, and then it's pulling it away, gravity is behind and pulling in front. And we can measure that wobble of the star, and that tells us the mass of the planet. But if the planet is up above, then you don't get that wobble back and forth from our perspective. The transit method is even more precise. Like with the radial velocity, the planet can be a little above or a little below. As long as they're roughly aligned from our perspective, we can make those observations. The transit method, it's got to be perfectly lined up. So the planet is moving exactly in front of the star and blocking it. And that does not happen very often. Like less than 1% of the stars in our vicinity are going to have a planet that is perfectly lined up from our perspective. We happen to get the Proxima Centauri planets, the closest star system to us, they're actually lined up. But there are other methodologies that will do the trick. So one is called astrometry, and this is what the Gaia answer. This is why I'm excited about the Gaia mission all the time. Is that astrometry, you are looking at the wobble. Essentially, the star is going to make this little spiral in the sky as the planet is orbiting around it, pulling at it with its gravity. And you measure the size of the spiral, and that tells you the mass of the planet. And if it's making a weird spiral, then maybe, sometimes it's going a little far to one side and less to the other side. Then maybe it's got 2 planets that are going around it. But the way that it's really going to take is the direct observation method. And this is where you just block the light of the star and you reveal the fainter planets that are around it. If there was no star at Alpha Centauri, like there are 2 stars at Alpha Centauri, essentially if you can block the light from the star so that you're able to see the reflected starlight from the planets, then we would see them. Our telescopes are powerful enough to be able to see the reflected light off of the planets that are orbiting around Alpha Centauri, stars out to hundreds of light years away from us. The problem is the light from the star is overwhelming. You can't see the faint reflected light of the planet because the star is so bright. And it's a factor of 10 billion to 1. So the star is 10 billion times brighter than the planet, and you have to block the light from the star to be able to reveal the fainter planets that are orbiting around it. And so this uses a technology called a coronagraph. And there is one on James Webb and there's one on other telescopes. And you're essentially blocking the light of the star to reveal just the planets that are around it. And so we would need a much better version of a coronagraph. And this is the plan for the upcoming Habitable Worlds Observatory and the Large Interferometer for Exoplanets. These are the two next big Earth 2.0 hunting telescopes that are going to be built, that they will have powerful coronagraphs. They'll block the light from the star. They will reveal the fainter planets that are orbiting around that. But you will still be constrained to the faintest planets that you can see. That we might be able to see the Jupiter-sized planets, we'll be able to even see the Earth-sized worlds orbiting around these stars, but we won't get a proper full listing of all of the objects in that solar system yet. But then better coronagraphs, more powerful telescopes, go into space. I would say, once we have the Habitable Worlds Observatory, once we have the Large Interferometer for Exoplanets, we will get a proper census of all of the star systems that are in our vicinity and all of the planets that are around those stars. So we are just a couple of telescope generations away from that being possible. Poker we discussed Vera Rubin and all the alerts being generated, but I haven't seen a lot of specific discoveries. Have there been any? And if so, what are they? Yeah, there haven't been a lot of announced discoveries yet, but that's just because astronomers work very slowly, that they are getting the alerts for the kinds of objects that they're interested in, and then they are booking time on telescopes. They're doing follow-on observations, and then they are gathering other data from other instruments. Then they're writing up their papers, they're getting it peer reviewed. And so it's still fairly early. There was like this rush of interesting discoveries made when Vera Rubin just came online, when they were doing some of their engineering first light work. We got these, like all those new asteroids that were discovered. And there was some asteroids that were rotating much more quickly than asteroids should. And that meant that they're probably solid, like chunks of metal or solid chunks of rock. That was really interesting. But yeah, I haven't heard a lot of news coming out of Vera Rubin yet. But it just feels like it's the calm before the storm, that astronomers have only been able to work with the data from this telescope for a couple of months now. They're still learning how to do it. Typically, a science paper will take an astronomer like the better part of a year to produce. When astronomers do observations with James Webb, they have a year of embargoed information. So they do their observations, they get access to the data, they get to sit on the data for a year to get their paper together before they do their announcement. So I would expect that we'll really start to see the flush of papers coming out towards the end of 2026. So stay tuned.
Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We'll call it Q&A Plus. This week's bonus question, which dwarf planet should we visit next? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you everyone who put your questions into the YouTube comments, everybody who joined me for the live show, the last one that I did before I left for Japan. I'm going to respond to a comment that I got about climate change, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Progetti, Brian Bodie, Caradine, Chuck Hawkins, Commander Balak, Darkfinger, Dave Gilton, David Matz, Enthralling Reading and Math for Toddlers, Eric Lindstrom, Evan.pro, James Clark, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneStepFarmers.org. Please follow my nephew at vbrick6994, Rank Haidu, Richard Williams, Sean Sargent, Stephen Falamoni, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zelda War Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got this question from Akamite. You've had no difficulty in the past on several occasions giving your opinion on climate change, aka global warming. Talk about a theory failing to make predictions. Here's some news you might spread, which would not be bad science. Global warming, climate change. World champion Al Gore is now touring with warnings of a failure of the Gulf Stream causing an ice age. So the thing that I say at the beginning of every live stream question show, and I mention this quite a lot, is that, I'm not a scientist. I am a journalist. And so my job is not, I have no opinions about various topics in space and astronomy. If you want to ask me, what are the holes that I find in some certain version of inflation or whatever, I cannot provide you any information. I am just a journalist. What I do is I provide you the scientific consensus. And I am consistent on this. So I provide you the scientific consensus on space and astronomy news, and I also provide you the scientific consensus on global warming, climate change, and what is happening to our planet. Now, I don't cover it very much just because it's not my beat. I read a lot about it, and I'm really interested in what's going on out there. But anytime I mention climate change, I promise you, I am referencing the scientific consensus, the thing that almost every single scientist agrees upon, and that there are people who are funded by oil companies who are looking to try to put off the consequences of climate change, or try to put off the consequences of having to pay for the costs of climate change as long as they can. And they have tons and tons of money, and they're doing a very effective job of trying to muddy the water as best they can. But reality, nature, is the ultimate arbiter, and we are experiencing it every day. I am in Kyoto right now, and they broke a temperature record. I left home, and they broke a temperature record. We're seeing temperature records broken. Anyway, I don't need to justify it, right? Like, obviously, the scientific consensus is in, and that is a very urgent thing that we need to take action on. And we see what's happening with the Strait of Hormuz, how dependent the world is on what is essentially an archaic form of energy production, and it's time to move to the age of electrification. Now, I'm going to use this opportunity to pitch and promote a bunch of other channels that I think are doing just a fantastic job of explaining the scientific consensus in ways that I just can't do it. So check out Just Have a Think, fantastic channel. Simon Clark, who is a climate change researcher. Professor Dave Explains does a beautiful job of debunking people who have specious arguments about climate change. And then Potholer 54, again, fantastic debunker of climate change nonsense. So if you want the scientific consensus on things, if you are consistent, intellectually consistent, then you should continue watching the channel. But if you want to pick and choose what you think is the scientific consensus, that's not how the scientific consensus works. And so you probably don't want to watch my channel. All right, we'll see you next time.